Good afternoon, everybody. My name is Oren. I'm part of the product management team for data platform, responsible for data resiliency. So anything that has to do with mirroring, with backup, those kind of scenarios fall under that category. Together with me today, I have Pete Gresko from our support team that will be co-presenting. And what we're going to talk about is mirroring technologies. What are the different mirroring technologies that we are offering? And more than that, what other things are out there? What would we recommend using? How many of you are using mirroring today? Okay. Good 40%. But I think, when did we first launch mirroring? 2010. And over, especially the last 2-3 years, it got to a point that I see the majority of customers using it. And for what it's worth, I think it's a given. A system should have high availability as an option, especially today when you look at data continuity and business continuity and how do I keep my business up and running 24/7, 365. That's definitely the requirement coming from my consumer's perspective. I know it's the same for us. Every time we get a support call about a system down, regardless of mirroring, somebody that had a singular system that had a critical failure of disk or whatever, database degradation, that immediately turns into a crisis because you have a system down, your customers don't receive any service, and that's a huge problem across the board. There is a way to address it though, and that's what we're going to talk about here. But when talking about business continuity, it comes in different flavors. Obviously, we're running our software on servers, on pieces of hardware, and there is some redundancy built into that. If you're using VMware, it becomes even simpler. But generally speaking, there's 3 levels that we're looking at here. First, from our perspective, from the database perspective, our objective in life is to keep the database consistent at all times. Once a transaction comes in, once we respond to whoever sent that saying we committed that transaction, that's it. It should be somewhere in our journal files, in our widget. It should be kept on disk somewhere. But if we lose power at that split second, it's already been committed somewhere and we can recover it. So that's part of the database design guides. The next level up is looking at things from a logical perspective. Now I have 2 databases and somebody committed transactions into both and there are dependencies. How do you protect against that? How do you either commit the entire transactions or roll back the entire transaction? How do you do things like delete star? So once that's executed, everything is gone and it's consistently gone. And the next level up, above that, once you ensure those 2, is providing the database availability. And on top of that, some of you guys are definitely building applications, then you need to deal with the high availability of the application itself. We do our piece on the database availability. So when you talk about the data server, we talked earlier about the availability of the data itself, but now the data server as a system, it's all about building redundancies. You need to have 2 systems so there's no one point of failure. If there's a volume, the LAN or something like that, sometimes you use shared storage so it can fail from one machine to the other if the machine fails, and sometimes it's the other way around. You want that LAN, that volume, to be duplicated somehow, whether it's RAID configuration or replication, so there are 2 instances of that. In case one of them fails, you can still access the other. So that goes across the board, across all levels. And I think if you look back to the IBM mainframes, they did really neat things in hardware. So everything was hot swappable, including a couple of the CPUs, and you can just pull out the CPU and they'll replace it and they'll continue to work throughout it. But fortunately for IBM and unfortunately for some of the customers, those were fairly expensive. And the more redundancy you built in, the more expensive it was. So you look at, then it migrated into the operating system level. And you talk about operating system level clustering. And the classic one is the Microsoft clustering services, but generally speaking, you have a passive, you have an active, some kind of a watchdog running between the two, and the minute it detects a failure, just fails over to the passive. So we support all of these clustering solutions, whether it's Microsoft, AIX, Linux, etc. Not going to talk about them here because they're slightly outdated and customers are migrating off them very quickly. The next level, with the introduction of virtualization, it becomes a lot easier to fail over the entire virtual machine. So as long as that virtual machine instance is stored somewhere and VMware has access to it or Hyper-V has access to it, it's easy enough to just fire it up on a different machine. And that became, I think, the most prevalent high availability solution out there. I'll talk about that a little bit, but generally speaking, it doesn't really qualify as high availability because you have to actually restart the machine, so you experience some level of downtime. Minimal, but some level of downtime. And a layer above that, and that's what we're going to talk about, is Caché Mirroring. And just like when you develop your application high availability, what we aim to do here is provide a flick of the switch kind of failover. So the downtime that consumers feel will be in the seconds, microseconds, depending on what the scenario is, but that's roughly what we're talking about. Some sessions might drop if you don't use ECP, and then the front end is supposed to reestablish that session, etc., but the interference is minimal. So the way to do that is fairly straightforward. The architecture is shared nothing, so you don't need to have shared storage where two machines can access the same data. What we do is that we take any transactions that comes in and actually duplicate it. This is done in a synchronous manner. Conceptually, when we look at those, we treat those two machines as a single entity. When you size them, both of them should be the same size. They should have the same amount of storage allocated to them, the same amount of memory. The underlying assumption is that a failover will happen. And when it does, that other machine, that passive machine that usually does not handle all the workload, now needs to handle production size workload. So size them the same way. Don't treat them as, oh, this is my primary and the other one is never going to get used, or if it's used, it's only for a very short amount of time. Again, design-wise, think of them as a single entity. Now, when we talk about mirroring, we're talking about the data server. I'll talk a little bit more about ECP and the application servers, etc., but keep that in mind as we go through it. So the way it works is that, per usual, all communication is channeled towards the primary. So the guy on the left we call the primary, and the guy on the right, the server on the right, we call the backup. That's our terminology. And the minute you commit a transaction, you update the patient record, you send financial transactions to the database. When it hits the primary, it does two things. It writes it to the database, to the disk, and sends it to the backup at the same time. This is synchronous mirroring, so from our perspective, once we get approval from the backup that it received that information, it's committed to two places. So you write to the disk, you write to the network, you get acknowledgement from both. At that point, you're good. You can continue to the next transactions in the list. There are also asynchronous mirroring. I'll talk about those as well. So once it's committed to both sides, it's failover ready, because now if a failover happens, the other side, the backup, already has that information, and it can continue to serve. It has the latest information. It's synchronized. So what happens when there's a failure? And a failure can be of any kind. You can lose a volume. It can be a network connectivity, so you cannot reach your primary. It can be multiple things, but it's something that we detect automatically. In the right configuration, we should detect it automatically. And then we simply trigger a failover. If you're set up on a physical environment or even on a VMware environment and you set up the virtual IP, we will take care of the IP rerouting by, when we're failing over to the backup, we take ownership of that IP address by distributing the right ARP message, etc. So from now on, all communication is automatically redirected to that backup server. The backup server does some level of data integrity check, applies the latest journals, and at that point, you're back up and running. Now, at this point, as the user, you will probably see, well, you should see some error messages in the C console telling you, look, first of all, there had been a failover, or first of all, here are problems with your primary. Oh, we triggered a failover, and that's what you'll see on both, depending on which machine you're looking at. At this point, we do not restart the primary automatically. It requires manual intervention by the user, so you have to go in there, understand what caused the failover, restart that primary server, at which point it becomes the backup, so they reverse the roles. And that's part of why I'm saying, why I said earlier that they should be sized the same way. So, as I mentioned earlier, both are interchangeable. They can and will replace roles multiple times throughout that life. And the way we detect failures, on each and every one of those systems, we have an agent running. So there's a watchdog. There's a constant network connectivity between the two, going back and forth, making sure, depending on the parameters that you set, the quality of service that you set, making sure that they're both alive and the backup is still the backup and the primary is still the primary. But as long as there are only two systems, you can always run into a scenario where they're both thinking that they are the primary. And this is where we introduced the arbiter, which is a third system. The arbiter is just a software component. It does not require cache, does not require ensemble or anything like that, but there has to be a third machine running that component, and he's the judge. If they both think that, that's how you set a majority, right? So there are two that decide that this guy should be the primary. That's what happens. Now, Pete will talk about these scenarios more, but you can and should trigger failovers for maintenance when you know that there's a scenario that you need to move to the backup, whether it's hardware upgrades, software upgrades, etc. So far we were talking about synchronous mirroring. So again, any update is written to the two systems in parallel. There is a long list of things, other things that are requirements. So synchronous high availability is great, but there's also a disaster recovery scenario. What happens if you want to move that data not between two servers that are physically close to one another, and close is within, I think the definition is 50 miles or 40 miles, whether there are regulations that force you, or just common sense. If you have a data center in Florida, you might want to have another copy of the data sitting on the other coast in a different country, more than 150 miles from there. The challenge it creates for synchronous mirroring is that propagation time. Once a write comes in, it needs to go to that partner, and by the time that speed of light goes back and forth, it's just too long, it affects performance. That's where asynchronous mirroring comes to play. So for disaster recovery purposes, you do not wait for that ACK to come from the backup, you just send the information to another system that sits somewhere else and assume at some point it will apply it and send you an ACK. So the time difference, the synchronization gap between those two systems might grow a little bit. It might be in seconds, it might be in minutes. It's better than not having it at all. So that's one aspect of it. The other one is reporting servers. And we talked a lot about, with InterSystems Iris, about the whole support for both data analytics and transaction processing on the same platform. But for many of you, you take that information from multiple locations, bring it into a single reporting servers, and then run all the reports on that reporting server. So that's another use case that's using mirroring. So the next thing is virtualization, and how does VMware does it? It's fairly straightforward. Once you have VMware, you have Caché running somewhere. Something happened to that host or to that specific VM instance. What VMware does is just restart that machine on a standby host. Usually the process itself the Caché startup will go through the data integrity check, replace journals, etc. But usually within a minute, 2 minutes, depending on your operating system and what was the load when it crashed, that's when it'll be back up and running. There is a way to combine the two. So this is becoming very common because now you combine our mirroring together with the virtualization high availability to achieve flick of the switch, but without actually buying two servers. In that scenario, if you have two machines running, and as we said earlier, it's the same scenario, but in this case, both of them are running on VMware. They can be, by the way, physical and virtualized as well, but then we break the rule of having them both be equal. And then if something happens to the primary, you have the automatic failover from our perspective, and VMware takes care of restarting that instance, that backup on a different host, so you still have full resiliency, etc. I said I'll mention ECP a little bit, and what ECP does for us here is twofold. First, it manages all of the application servers and the connections going into that mirror data server, so when a failover happens, there is no effect whatsoever to the application servers. If you don't use ECP, as I mentioned earlier, some of those sessions might need to be recreated, etc. So there's that piece of the puzzle, plus the whole redundancy of application servers and the ECP connections, etc. So our mirroring manages the data server resiliency, ECP manages the application, the outward going connections, etc., to provide that kind of resiliency. I will upload this, I think it might already be available, but if not, we'll definitely upload this. I'm not going to go through and read all that, but basically just summarizes what I talked about so far. And at this point, I'll hand it over to Pete.
And yeah, these slides are, I think they're already available in the app if you want to look at them. just click on the session, there's a PDF. So what I'm going to talk about first is using mirroring for migration, which is something that's not really a standard way to use mirroring, and it's just kind of a good tool that we have that allows you to do something a lot more efficiently in terms of downtimes. So I wanted to talk about that a little bit. So to set up a little bit, we have to talk about what a migration might look like without mirroring. And when I say migration, I mean a migration from maybe one server to another server. You're switching operating systems, or you're just installing a newer version of Linux or AX or Windows, or you're switching between them. Maybe just swapping out a disk, something like that. So when someone calls into support and asks, how do we do that? This is kind of what it looks like. You'd set up a new instance on this other machine. After you do that, you'd restore all your application over there. And then once that's done, you'd restore journals since that backup finished. And you can repeat that last step as much as you want, just to try to close in on the time that you were at when you finally do start your downtime. So then, when it's time to finally cut over, you'd start a downtime, shut down on the old server, and then restore all the remaining journals, because there's going to be some, even if it's just part of one. And then you'd point your users to the new server, and then you'd be good to go. And this is kind of what it looks like normally. And now I want to talk about what it looks like if you add mirroring into the picture. So with mirroring, the setup is similar, but it makes the downtime much closer to zero. So I don't need to go through all the steps here, but it's very similar to the other one. You just set up mirroring on this other member, connect it as an async member, because like Oren said, maybe you're moving data centers too. This is just a way to avoid affecting production. And then when you're finally ready to go, you'd promote that to a failover member. Presumably this new server is not just equal to the other one, but maybe even better in this case. So when you're ready to go, you'd start your downtime, shut down on the old server, and it would fail over to the new one without you needing to do anything. And then you just point your users to that new server, and that's the end of the downtime. So there's a lot fewer manual steps during the downtime if you involve mirroring. So that's the main advantage here, and time-wise. And then when you're done, you'd remove the original server. So you can add a couple things onto this that make it even easier. The first one is a virtual IP, which is basically it's an IP address that's managed by mirroring instead of managed by your network team or whoever's managing the server. And it can swap between mirror members. So in this case, the setup is the same. You just start your downtime and shut down, and the downtime's over because it fails over. Any open connections would be broken, but they would be available essentially immediately afterwards. And then again, you'd remove the original one from the mirror. And one other piece that Oren talked about earlier that can make it even faster is ECP. So if you have ECP, I don't know if many of you are using that, but you point your users at these application servers, and you're migrating your data server. The application servers are aware of everything in the mirror, so you do the same setup, and then you shut down just like before, and it fails over to the new server, but any connections aren't even interrupted. So users might notice a slowdown, but they'll never lose their connection, making the downtime basically zero in a cutover. Any questions on the migration stuff before I move on? We should have time at the end too.
With ECP, you don't need a virtual IP?
Well, as long as all your users are connecting to application servers, you don't need a virtual IP. Because ECP, even if you have a virtual IP, isn't using it. Because it just knows what all the regular IPs of the mirror members are. So it just goes to the right one.
So when it switches mirror members, it just tells the
Right, yeah. I mean, the app server would try to connect to the old one, realize it was down, and just connect to the new one. And the way that it's built in, it allows it to recover its connection without losing anything, as long as the failover is relatively quick, which it is. Any other questions on this for now? All right. So next thing I want to talk about is mostly some upcoming improvements. To explain those, I do need to go into some technical detail. I don't want to go into too much, even though I could. If you want more technical details, I will be here in the Tech Exchange after this and tomorrow morning, the WRC table. So I want to talk a little bit about mirror communication and how it works. Oren alluded to this earlier, but basically the way mirroring works is you've got two processes on the primary, one sending journal data to the backup synchronously, and then another one waiting on the acknowledgement to consider the data durable. When I say durable, I just mean the primary is waiting to actually write it to the databases until the backup has it. That way it prevents them getting out of sync. So there's one process on the backup handling both of these. Basically reads the data off the TCP pipe, tells the primary it got it, and then writes it to disk and repeats over and over. And this is the way it worked before 17.1. In 17.1, pretty major performance improvement for the backup, and async members keeping up. The writes to the OS for the journals are now asynchronous, so it speeds things up a lot because the backup can accept a lot more data without actually having it written to disk and needing to wait on that. So the main reason that's a lot faster is because it can stack a bunch of writes on top of each other. So if one write is really slow, we can just do a giant one afterwards. Or if there hasn't been that much data, we can just get it. Okay, so the next thing I want to talk about is DR promotion. I talked about this a little bit as part of the migration, but I kind of glossed over it. Promotion is basically you just hit a button and your disaster recovery member can become a failover member, whether you want to just promote it to being a backup at the time because you want to cut over to it to do some maintenance on your primary, or if you actually have a disaster and you need it to become the primary. So now in 17.1, if you are cutting over to the DR in a true disaster where you can't contact the primary, it will now contact other async members to see if they got more data. So if, say, your primary data center is out completely, but you have maybe a reporting member in another data center and a DR member, and maybe the reporting member got more of the data before the disaster event than the DR got, now the DR will pick that up before becoming primary, just to make sure everything stays as up to date as possible and in sync. And we also allow for an operational step before this, just if you want to manually validate anything on your DR before it becomes primary and you let users onto it. Okay, the last new thing that I want to talk about is parallel dejournaling. So currently, the way that mirroring works, we talked about journal files getting sent between members, but basically you've got one process on the backup or async member that's going through the journal file and actually making those changes to the databases. And that was starting to become a limitation in terms of scalability. So starting in 17.2, there will now be up to 4 of these updater processes that can make these changes at the same time. Because we need to make sure we do everything in order, the way this works is they will all, none of them will share a database. So if you only have one database, you can't really take advantage of this, but if you have 4 or more, each updater will pick a different database and apply updates still in order, but not necessarily at the same time as the other ones. But we still keep track just to make sure everything's okay. And this feature is not currently used by shadowing or journal restore at startup, just by mirroring and not for reporting members. Any questions about any of the new stuff? All right. So a couple of things to watch out for. A couple of you said you use mirroring, but not all. And maybe the ones who do can speak to these actually being problems for them. So the first thing is journal space on both the primary and the backup. So this becomes an issue because mirroring is very careful to make sure it has all the data so that backup and async members can keep up. So if you shut down an async member for maintenance, the primary will make sure to keep all the journal files so that the async can catch up eventually. This is a major improvement from shadowing where you would have to manage it yourself. But with mirroring, we save those, and sometimes that can cause problems because the primary is now holding journals for much longer because someone forgot that an async was down. I actually, about 2 hours ago, had a customer crisis call about this exact thing. So there's also another step when you're setting up the mirror. If you're using SSL, you just have to approve mirror members, both backup and async members. Just an extra step that a lot of people sometimes forget to do and then don't understand why things aren't connecting. And then another thing that people sometimes run into when they are setting up a new mirror, if they haven't done it before, is you can't actually restore these databases from the primary to the async or backup until after you've created the mirror. Because when you create a mirror and add a database to it, it keeps track of exactly where it is. It has checkpoints in it. That's how we make sure that everyone has the same copy of the data. And if you back it up before it joined the mirror, then that doesn't really work. And finally, just wanted to mention the communication layer between all components. You just want to make sure that all your mirror members can talk to each other, and your users can talk to all your mirror members. Because if you can't get users to connect to your DR member that's in another data center, and you have to cut over to it, it's pretty useless if no one can connect to it. So that's pretty much all I have. Here are some resources you can use for mirroring. The developer community, there's a mirroring tag. I'm looking at that a lot, as are quite a few others. There's a high availability strategies white paper just available on our website. And the documentation for mirroring is quite good. I actually believe that. I've heard a lot of complaints about our documentation before, but I do believe it for mirroring. And if you want to learn more about some of the things we talked about, there's our learning website and classroom training and just the general documentation. So where to go from here? A few of these sessions, most of them already happened. There's one tomorrow by Mary Oldfield at 9 on the pros and cons of virtual environments. I think that's the only one on here that hasn't happened yet. And please complete the survey. Tell us how you thought we did. And the session recording should be available soon after this. If not, the first one might already be there for all I know.
Just one more point that I don't know we missed, you didn't put it there. When you think about mirroring, what we do, I think we explained, is mainly database replication. Everything that is outside the databases is not mirrored to the other side. So all the binaries, everything that we need for CSP, etc., those need to be replicated separately from mirroring.
Yeah, mirroring is a database replication technology only. That's it. So we got plenty of time for questions. And if you, yeah.
I haven't looked at the 2017 documentation yet, so maybe I can answer my question. I work for the VA and we shadow all VA medical centers, 4 different regions, over
Shadowing, as far as I know, isn't being enhanced. There have been bugs with that kind of stuff. Those are fixed.
We're using 2014.1.3, and I think,
There's probably something in between there. I think there definitely is.
is there a release, like a repeat on one?
Yeah, we released an alert on Dejournaling missing some stuff. I think in 2015.
So it's like fixed in 2015.
Yeah,
I think the VA plan is to update everything to 2017.
it might even be in 14.1.4. I'm not sure, but yeah. But I mean, also the problem with shadowing is if you have different data, there's no real way to know why. So with mirroring, it's keeping track of, it's making sure, or at least attempting to make sure, that everything's the same. So if at any point you have two mirror members that have different data, it must have been a bug. But with shadowing, you can kind of do whatever you want and just tell the system that these are the same. There's no way to know. I mean more in the initial setup. I mean, shadowing still knows the checkpoints and stuff, but I could just take two random databases right now and tell a system that they're copies of each other and start shadowing, and I'd get all the new changes here, but I wouldn't have anything that was there before. That's something that mirroring gives you that shadowing didn't. And also shadowing, there's no protection on, like I could just go into a shadow system and make some changes.
Right, and the shadow source
Yeah,
doesn't know.
right, and mirroring doesn't let you do that.
Maybe we should switch to mirroring, but that's been discussed.
Yeah.
So a mirrored database it's locked, you can't change it.
You can have a reporting member that's read-write, but in terms of what we were talking about, the backups and DR asyncs, they're read-only on that side. Only on the primary can you make updates.
I'm sorry, I should have followed up the errata that you mentioned after, or the release that we're using. Is there linkage to that on the InterSystems site somewhere?
The alert,
Oh,
you mean?
yeah,
Yeah, it's just the support.intersystems.com. There's like an alerts feed. Yeah.
you can also sign out for the alerts.
Yeah. Fortunately, there aren't that many of them, so if you wanted to sign up, it's not going to flood your inbox. Any other questions? All right, well, like I said, I'll be in the tech exchange the rest of today, tomorrow morning, if you have any questions. But thanks, everybody. Yeah.